Hello everyone. Today we have the pleasure of welcoming Professor Randhir from India as our guest lecturer. His research interests include blockchain technology, information security, cryptography. I believe today's lecture on blockchain technology and security will be a fantastic lecture. Let's warmly welcome Professor Randhir to begin his talk. Sir, you can start now.
Okay, thank you, Rehan. Today topic actually, I will discuss access control technique, opportunities, challenges, and future directions. So I will start with the outlines. Slide is not moving. Okay. Yeah, now, so this is the outline of presentation. So what is actually access control, types of access control, key components of access control, and common access control matrix, benefit of access control, what are the challenges comes in access control, best practices what we can use for access control, and what are the future research direction in access control, and then finally we will discuss the conclusion of access control. Basically access control is the fundamental component. I will discuss in terms of cyber security. This is basically fundamental component of cyber security, and basically is used to unauthorized access. If somebody is unauthorized user is trying to access the information, there actually we can go with the access control type of mechanism. The basic purpose is to define the security policy to protect your data and restricting the access of unauthorized user. But while doing, maintaining this access control approach, you have to use security triads. That is actually CIA: confidentiality, integrity, and availability. So these three things should be maintained. Even if you are designing this access control technique, in that case, you have to maintain these CIA triads. And the major components of access control is first, authentication is needed, authorization is needed. So when user is authenticated, then user is authorized, and based on that, you have to give the access. So this is actually basic fundamental. Whenever you are applying this access control, CIA should be maintained. Now these are the types of access control: discretionary access control, mandatory access control, role-based access control, attribute-based access control, and rule-based access control. So all these types of access control, we will see one by one, and where to apply these access control, what are the components under these access control. So we'll start with discretionary access control first, and then we'll move forward to remaining. So discretionary access control is nothing but the particular owner will decide who will access his data or his transaction or his file. So it is totally depend on the owner. So suppose I am the owner of my resource, my transaction, then who want to access or who will access, that I will decide. So basically it's owner oriented, user oriented. So allow owners to modify the access control. Suppose today I have given access control to some group, tomorrow I can remove this access control. So this is all maintained by, this access control is maintained by that particular user. So from user point of view, discretionary access control is designed by the user, that owner of the particular resource. So basically it is very much flexible, user friendly, because owner is deciding who will access my data. But this disadvantage is, less secure, permission can be easily shared or misused, because one user or one owner is maintaining this. He can misuse this access control approach by not issuing the exact access control to some group, issuing the access control to some other group. So all this kind of disadvantage will come. But the good thing about this particular access control is it is maintained by particular user. Sorry. Now, as we discussed, actually, this user autonomy is there. So total control by the user. So DAC is convenient for individual file sharing. Basically, it is used in file sharing. So suppose I have shared one file, and who can edit that file, who can not access that file, that all kind of permission, uh, permission access control that user can provide to the individual user or any group. So this is all about the DAC. Now these are the key components of DAC. So ownership, obviously ownership is the, I mean, who is created that particular data or transaction or file or resource. That person will be the owner of that particular resource. And some permissions are there, like read permission, write permission, execute permission, and full control. So suppose I want to give permission, read permission only to particular user, that we can provide with this discretionary access control. That user can provide write operation, execute operation. So all this kind of operation and access permission will be given by that particular owner. For that, owner maintain one table. That table is an access control rule. So access control rule will be decided by the owner. So this is also known as access control matrix rule. So suppose user one is there, user two is there, user three is there, and one transaction is there. So suppose user one is the owner of that particular transaction, then user one can read the data, write the data, execute the data. I mean, full control of that particular data is there with the owner. The other two users can have read permission only, or maybe one user will have write and read permission, other user will have read permission. So that all set of permission will be taken by that owner. I mean, given by that owner. Assignment of the permission and removal of the permission. Everything will be taken care by the owner, owner of the transaction. Then ownership and permission basically can be you can consider one example. Suppose one company is there and having a shared network drive, and each user has control over the file. They create and can grant other access as needed. Here, I mean, the DAC scenario is, suppose LIC is a project manager, creates a file containing sensitive project information. As LIC is the file owner, she has the discretion to decide who else can access it. So Ellis grants and write permission to Bob, a team member, so he can collaborate on the document. So other Bob as a team member can collaborate on the document, can read and write or execute permission is given. Sometimes Ellis can restrict access to other employee who is not the team member outside the team. So all unauthorized access can be restricted by that owner. Now there are two access scenario: direct control and delegated control. So direct control is basically Alice can modify permission at any time. If you decide that Bob no longer needs to access, so all this removal of permission and granting the permission, that is known as direct control. And delegated control is basically uh, if Bob needs to add some other member in that particular project, then he need to take permission from the Alice. So this is actually delegated access. When Bob wants to access any member in that shared uh, to read and write and execute the transaction or data or file, then first Bob has to take permission from the LEC, because LEC is the owner of that particular resource. So this is the way actually discretionary access control work. So owner will decide. So this image is telling you owner will decide which group and which user will access my data. And some transactions, some objects is there. So it can be file system, it can be database system, it can be simple transaction, any record. So any file. So owner will decide who will access. So advantage is basically this is flexible to user. So that provides resource owner full control over the data and who will access it, and easy to use, manage. So user can manage the permission without needing complex rule. with the individual data management that owner can decide. Then data can be modified by the owner, can be shared, so all adaptability and in collaborative environment can be done in DAC environment. Now this is file sharing. One team file sharing example is there where each team member has control over the document. They create and can get grant or revoke access as the project progress. So initially, 5 members were accessing the data. Then when the 2 members completed their task, then owner will decide whether they can access the data or resource or not. So that permission can be revoked. So this is one example. Now limitation is basically DAC flexibility can lead to accidental permission error because individual is assigning, individual owner is assigning. So we should be very vigilant in that case. So any unauthorized user is getting permission, then maybe they will misuse or they will give potential breaches on over the resources. Then large organization basically managing permission of individual file label can be very complex because so many groups will be there, so many users will be there. So in the large scale, it's very difficult to manage with many users. And suppose single resource is there, then okay, fine. But multiple resources are there, multiple users are there, and multiple groups are there. Then managing this DAC is a little bit difficult. So I mean, this problem actually ownership problem now is transformed to centralized access authority, and that centralized access authority kind of access permission is known as mandatory access control. So mandatory access control is basically central authority gives the permission to user. So suppose one admin is there and admin will give permission to individual user. So in this case, in mandatory access control, basically two things is very decided by this central authority. One is uh, in which label that user is basically label is decided, security label is decided by this security level of document is decided by the user. Security label is decided by the central authority, and as well as clearance label is also decided by the central authority. So clearance label is nothing but is for object, and security label is for that user. So suppose I am the user, I am falling under the particular label, label 3, and there is some object or resource which is having label 3. So if I am in the label 3, then I can access the resource of label 3. So some label is decided. So label 1, label 2, like that, label is decided for the resources as well as the user. So if I'm in the label 3, I can access the resource of label 3, as well as I can also access the resource of label 2, label 1. So top label user can access the resources of below label. So this label is decided by the central authority. So suppose one organization, one chairman is there, then he will be coming in label 4. So label 4, all the resources he can access, as well as he can also access label 3, 1. So all this below level access he will have. But below label cannot access the top level secret information. So this label is decided by the central authority. So basically, it is used in the government services, military, where data is very much sensitive and confidential. So one label of admin level can access some different information. Below that, some label is there, then they can access some different information. So every level will have their own resources and they will access this information actually. So this is all about this mandatory access control. So it's highly structured basically security model, and two good concept is given. One is BIBA model. BIBA model is given for this MAC, and one more one more model is given in mandatory access control, that is Bell-LaPadula model. Bell-LaPadula model. So these two model is given, Bell-LaPadula model and BIVA model for mandatory access control, right? So in that, actually what they did for generally operating system access, but same thing nowadays it is followed in cyber security system. So label is decided, and based on that label, resources is accessed. So so similar, like, if you are user in this admin, then you can access different resource. If you are not in the admin label, you can access some different resource. Now these are the two things. Two label is there. One is security label, one is clearance label. So security label is decided for the resource. So top secret resource, so one security label. Then secret resource, other security level, confidential, other security level, and then unclassified, which is general information. So that is actually comes under the unclassified label. So security label is decided for object or resource, you can say, and clearance label basically is decided for user. So suppose clearance level 3. So clearance level 3 is nothing but confidential. So all confidential information level 3 can access, as well as unclassified information can be also seen by that user. If any user in the top secret level 5, now it is only 4 level: top secret, secret, confidential, and unclassified. 4 uh, label is here for the resource. So 4 label of user will be there. So each level will have different access. Top level always will access the below level information, but this should not be in the reverse. So these two policy basically framed in mandatory access control, and this policy is basically enforced strictly because of confidential information sharing. I mean, in DAC actually everything is decided by the owner, but here actually it is controlled by the central authority. Central authority will give the permission, decide the label, and then give the permission to each user and their access. So these are the classification of your data, resource, or file, or whatever transaction you are using. In that will be defined as a label, different label, and then role of each of the user will be decided. So like senior government officer has top secret clearance label, can access all level of data. So basically, whoever is in the top secret label, uh, then he can access all the information: top secret, secret, confidential, and unclassified. This can be changed also. This actually I'm telling in terms of Bell-LaPadula model, because Bell-LaPadula model follow this this mandatory access control. So in that scenario, I'm telling this classification, but this can be classified in different way also. I mean, based on your requirement. Suppose you are telling that resource classification 4, or you can increase your resource classification 5 and user classification 5. So user classification 5 can access resource classification 5 as well all the resources below in that classification. So this is the way actually. So senior government officer is having top secret clearance level, can access all level of data. Similarly, a researcher can have the access of confidential clearance level and can access the confidential unclassified information, but cannot access secret and top secret information. So reverse is not true actually. So top secret can access all the information, but below cannot access the. So like that. So intern has unclassified clearance label. So any information which is general can be accessed by all the user. They can access actually. There is no permission needed actually, unclassified type of information. Then this is what actually one image you can see. User is there, and their privilege is given. Privilege label. So user is coming in which of the label. Based on that, object will be resource will be granted. So this resource can be anything: your file, your one single I mean database or record, or whatever information you want to keep in your access control, that you can keep. So based on the user label, you have to decide which of the information that user can access. So top secret, secret, confidential, and unclassified, or you can say public. So these are the user and label. So this is actually mandatory access control. Now benefit is actually enhanced security. So unauthorized access cannot be done. If you are not in that label, you cannot access. Uh, and similarly, reduce risk of breaches, right? So any kind of breaches is there, security breaches can be reduced. Since you cannot modify access control, it is controlled by the particular centralized admin. You can say TPC, third party uh, uh, user, a third party admin. So earlier in discretionary access control, owner is the everything for the resource. He can modify the access, everything. But now it is handled by the central authority. So security breaches is not there. Then this particular label can be used in healthcare, finance, or any sensitive information where classification is required. I mean, information classification is required. That can be done in mandatory access control. So suppose doctor is there, doctor will access different information. Then some medical practitioner is there, they will have different access. Patient will have different access. So every classification of the user will have every classified set of resources to access. So this is actually what compliance and is resources access, right? So this is the benefit of mandatory access control, not handled by the single user, and is basically handled by the centralized authority. And security cannot be breaches as he cannot modify the access control. Everything is decided by the admin. Now limitation is basically it is inflexible. The rigid nature of MAC is difficult to have the changing needs. So if suppose uh, tomorrow you need to change the label of particular user, you have to again go and change your particular rules of mandatory access control, and then you have to do it. Then classifying data correctly, which data will come in which of the label, it's very difficult task to give this clearance label so that user can access. So how to decide which data will come in top secret, in secret, I mean classified, unclassified. So this all decision is very difficult. So this things actually required at the beginning by the admin to decide which data should come at which label. Then again user frustration. Tomorrow you are accessing, today you are accessing, tomorrow your label is not, I mean access permission is denied, then you will not be able to access. This is kind of user frustration. If you have removed from that label, you will not be able to access those information. So this is also one kind of limitation of mandatory access control. So now to this mandatory access control, one advantage was there. Basically it was not controlled by the discretion, I mean user. It was controlled by the central authority and given the permission based on the label. But managing this which classification of data and all, it was very difficult. Now actually role based access control came, where uh, this label is not basically decided, but role is decided. So which role basically user is belonging to. So if user is belonging to some admin role, he will get some different access permission. And if user is belonging to normal user, then he will get some different access of resources. So this access control is basically designed based on the rules rather than classification of the data and classification of the user. So that role-based access control is provided based on the role, which role that user is belonging to. Almost similar to mandatory access control, but some part is flexible in role-based access control. So role-based access control is widely used access control model in cybersecurity. Nowadays, all these organization, industries using this role-based access control and maintaining the particular rules, job, I mean, based on the job function. And with that particular job of the user, that set of privileges and access will be provided. So I mean, you don't have to provide access to each of the user, just you see the role of the particular user and access will be given accordingly. And rule-based access control is basically popular over the industry. As I told, every team will have different set of member, and each team will have one admin and can decide different access control for the different user. So this is basically maintaining role-based access control. It can be, I mean, in mandatory access control, basically dividing overall of the overall organization. But here actually, inside team also, if one team is there maintaining some project, then that project manager will be coming as a one role. So in individual, in a smaller group also, role-based access control can be applied. It is not mandatory to apply all over the, um, organization. In a smaller group, also this role-based access control can be managed. So suppose three project one company is doing, so three different teams are there. In that particular teams, they can go with the role-based access of the particular project, role-based access of the particular project. But in mandatory access control, overall you have to decide. Overall, you have to decide your data and the classification of user. So that is very difficult. But here actually, a smaller group of team also role-based access control can be maintained. So different roles will be there, different permission will be given. Again, permission same, read, write, update, delete, all this information, CRUD operation can be, permission can be given. Then one user can use more than one role also. So one or more than one role can be assigned to one user in this role-based access control. One another kind of role can be provided like session-based, session and mutual key generation based role access. So suppose you are logging to one website, you are accessing, one role will be created as your session ID. I mean, the time you are using it, that role will be given. It's a temporary, basically temporarily activated role. You have used that as a user role. You have done all this process, and then once you come out, then that session will be deactivated. So session based mutual authentication or key generation, these all types of authentication comes under this role based access control. That is known as actually temporary role based access control. So temporary role based access control is nothing but session and key generation. So suppose in if I'll take example of any website you are using where one session is created and managed to your role, and once you have used that, you will log out, and once you log out, that session will be deactivated. So that is also one role, temporary role of role assignment to the user. So whichever role you are entering, one session will be created. So different role, different permission can be given, and more than one permission can be also given. More than one access control can be also given to the user in role-based access control. Now, one scenario is taken here. So suppose one company is there, and we have that company is having sales department, finance department, IT, and human resources department. Different department will have different type of access, right? So based on that, role and permission can be granted. So as you can see, sales team member have access of CRM, customer resource management, to view and edit customer record, but do not have access to payroll information. So that can be restricted. So based on their role, permission can be granted. So this all set of uh, access control is provided based on the role of the user or team of the user. So suppose finance team will have access of payroll system, but cannot access the any CRM data, confidential engineering data. So that cannot be given. Similarly, human resource will have the access of employee record, payroll, benefits, performance, all this data, but they should not have access of data and IT system information. So this all restriction will be provided or given based on the role. So if role is given, that role will have the access, and one role can have multiple access also. And management is this role-based management can be done in a smaller group as well as larger group also. But if it is going in the larger group, it's very difficult to manage because in number of roles will be there, in number of permission will be there, in number of resources will be there. Then managing at the large scale, RBAC will be difficult. So it is very useful when smaller group of member is using that particular resource, in that case, this role-based access control is good. So same actually example is taken, user assignment. So John is a member of finance department. He assigned to finance role, and this will grant him access to payroll budget data, but restrict him to for the CRM engineering database. Same thing actually. So this is the role-based access control. So admin will assign the user with different role, and this role define the authority level. So which role actually you belong to, and then access control based on that actually access control will be provided. So all the permission are authorized based on your role. So which role you are belonging to. If you need more than one role, that can be also granted in role list. So this is actually role-based access control. This is also known as coarse-grained access control. Sometimes coarse-grained means a particular in larger scale. Role is a larger scale, right? Role is a larger scale. So one scale is there. Suppose doctor. Doctor is having some different access control. Advisor is having some different access control. Emergency ward will have different access control. So at the larger scale, one role is taken, and for that role, that access is provided. So this is actually entire thing is also known as coarse grained access control. So one role is taken larger scale, and that role will have some access permission. That is the thing. So this benefit is basically it is scalable. When tomorrow one another user is coming, we'll add the role and give the permission. Enhances security basically, because if that is the role, if suppose one user is having one role R1, he can access the resources based on that role R1. Or suppose admin role, admin will have that particular resource access. So that resource access is based on their role, right? Now this is basically when it will be, limitation when too many roles is created at the large scale. So when your organization is maintaining large number of rules, large number of resources, to maintaining this access control permission is difficult. So to modify this, actually one another control technique came, attribute based access control, where uh, different set of attribute will be also included with the role, and based on that access control will be provided. So next actually role we will see role attribute based access control, because role based access control generally fails when large number of roles is created by the organization and permission is given for the large number of resources. So in that scenario, managing of different roles and giving permission is very difficult. So for that, attribute based access control came. So with role, some attribute will be also given. So this is also known as basically fine-grained control based access control. So role will be there, but in that role also will have some attribute. So if this is the role, if and this attribute it is matching, then this permission will be given. So based on this attribute access control, basically role will be there. Obviously, role we have to uh, take the first attribute, and then some different attributes should be added with that particular role. So as you can see, suppose user is having some role, at what location he is accessing that particular resource, at what time he is accessing that resource, which device type he is using, which network he is using, so which IP address he is using. So all these attributes can be combined in attribute-based access control. So suppose one doctor is there accessing data as a role of doctor from the location of inside the hospital, so he can access the information of patient. The moment he is going away from the hospital, he is trying to access from the home, it should not be permitted. So location will be one factor, time will be another factor, what type of network he is using, what kind of IP address he is using. So this is general actually I'm telling, but these things can be used in the other way of uh, access control permission. So suppose one role is created, I'm telling that if it is this is the role, and at this is the time actually he is accessing, he can access the particular resource. Otherwise, resource should not be access should not be given. So other attributes can be added with that particular role. So that entire thing, role plus the attributes, is added, and this is known as attribute-based access control. So at the larger scale, we can manage. So attribute-based access control is dynamic basically. So grant access based on the attribute of the user, resource, environment, action rather than predefined role. So I mean, in the role-based access control, basically it is known as course access control. Means one larger scale we are taking the role and we are giving the permission. But here actually not only we are considering role. With the role, other attributes is also there. So other attributes will be also considered, and then this attribute-based access control will be decided. So based on that location, time, and the environment. So user attributes will be first priority. So suppose what is the role of user, job title, which department, clearance level, at what level actually he is. So this attribute-based access control can be used with role-based access control, can be used with mandatory access control. So you can combine this, you can make it the hybrid approach. So mandatory access control, you have given the label, security label, let's suppose, for the user. I mean, security clearance label. Now you are telling that this is the clearance label, but if this is, another department is the clearance label, so or admin is the clearance label, and you are telling that clearance label is the admin, and location is this. If this is the location, you can access it. So you can combine the attribute-based access control with the role-based as well as mandatory access control both. So you can make it hybrid access control permission using this attribute-based access control. So at different attributes for the user, different attributes for the resources. So different attributes for the environment. So date, time, device type, IP address, location, everything, every attributes will be designed as a policy and can be granted access permission. So the example which I told you, this example is doctor is trying to access the data within the hospital within that particular certain time. So particular time is given. In that time he is accessing, it is permitted. He not accessing, this is not permitted. So that all kind of attributes can be added to role based, and it can be added to mandatory access controller. So this is the security level, and this other attributes is also added. That will come under the hybrid approach of the access control rule. So here actually, like user attribute is taken, job title, department, security clearance, location, and two role actually is taken, branch manager and finance analyst. And resource attributes is confidential, public, and internal use. Three level of resources is decided. Now access time is given, company issued laptop or device type, location, time, everything is measured. And attributes, whether he can read or edit. So all this permission, everything is decided in terms of attribute. And combining these attributes, attribute-based access control policy is designed. So a finance analyst is authorized to view confidential document only when accessing them from the company internal network. So within the location, if he is accessing, he can access it. So if he is trying to access the external network, he's sitting somewhere in the coffee shop and he's trying to access, that is not coming under the network or some other Wi-Fi or some other place he is using, that should not be that the access should be denied actually. That is the attribute based access control say. So your role is there, but with role some other attribute will be also added. So that is actually attribute based access control. Similarly, branch manager is coming with the confidential document, view and edit confidential document, but restricted from accessing top secret document. So top secret document cannot be accessed by a particular branch manager, as he is not coming. He can only access the confidential information. So resources is having some category and some attributes will be added, and then you can that permission is granted. So basic scenario of attribute-based access control is, attribute-based access control is not a single different set of access control. You can combine this with the mandatory access control. You can combine this attribute-based access control with the role-based access control. So role will be there and some different attribute you can add. So that scenario you can create. So I mean, alone attribute-based access control does not make any sense. If you have role, if you are adding some attributes, then you can make it this hybrid approach of access control. So dynamic decision making can be also designed based on this attribute-based access control. So suppose finance analyst try to access confidential file from home on the personal device, then deny the permission. So based on the location and time, these attributes can be given. So I mean, this is the attribute-based access control. So course grained you have to take. Course grained means what? I mean, role-based access control. Role should be there, and then attribute should be also added. So here actually attribute. Actually, one example attribute is name, address, age, gender, mobile. All attribute is taken. Then suppose email ID is different. Doctor is using some different email ID to access the data. Then this should be denied actually. So fine grain means inside this particular bigger role, this attribute is also added. So if he is using company email ID and then he can access, and also the within the location, within the time frame, every attributes matching, then he can access. So attribute must be added to the role. That scenario should be there. Attribute alone is not access control rule. I mean, you have to use this attribute with access control with the role base and mandatory access control to design dynamic access control permission. So benefit is actually everything you are seeing, particularly in terms of attributes. So this is also known as what? Granularity. So you are seeing each of the attribute, whether this attribute is correct, validated, then only permission is granted. Otherwise, permission will be denied, basically. Right. For dynamic access, you can design in the real time. So suppose some other location data is used or trying to access the data, then you can check the location, you can check the time. So everything, these attributes can be added in runtime scenario, but dynamic access permission can be designed with the attribute based and combining this role. So this is actually dynamic access control permission can be designed. So I mean, same, it can be healthcare system, it can be in healthcare system, financial industries, where different roles are there and different attributes you can add to design this dynamic access permission. So as I told you, doctor is using the patient information within the organization, he can access. Outside the organization, he cannot access. Doctor is accessing the patient information with the particular hospital mail ID, he can access, otherwise he cannot access. So all this attribute will be added with the role. So doctor is the role, but attribute is the mail ID, attribute is the location, attribute is the time. So this role plus attribute can be added, and you can say that this is hybrid approach of access control. So this is one remote access policy. So using outside the permission, then he cannot access. So same example. Limitation actually complex to implement because different attributes policy you are maintaining with each attribute. You have to validate each attribute. So this is complex. Then overhead is basically every time dynamically you have to check whether this attribute is matching or not, this time is matching or not, location is matching or not, particular email ID is matching or not, role is different role, permission, everything you have to access. So it's very difficult to manage. This is kind of overhead, but it's in a smaller group of team, this is very suitable to manage attribute based access control because role is there and attribute can be added to manage in the smaller group of a smaller size of group, because role based and this can be combinedly used. Rule based access control is again another extension of attribute based access control. Basically, this is attribute based access control only, but some rules are given. So particular if, like if then else. So if this then only you can do this. So rule-based access control is the extension of your attribute-based access control. So alone attribute-based access control is cannot be applied. Attribute-based access control, as we have seen, attribute-based access control can be applied with other role-based access control as well as mandatory access control. Similarly, rule-based access control is the extension of attribute-based access control. So this should also have some role. Suppose one user having some role, doctor, and then rule-based can be commonly used. So this attribute-based access control and rule-based access control, these two access control basically used for designing of hybrid approach of access control. To design this attribute-based access control and rule-based access control, you should have either role-based access control or you should have mandatory access control. If these two are there, you can design it. So certain rule is there. Let's suppose admin is there, and suppose admin is there, and you are giving this attribute like location. Now location is one attribute, but you are setting some rules. What is rules? Less than 500 meter. This is one rule. So location means less than 500 meter or equal to 500 meter. This is actually one condition you are giving. This condition is known as rule. So suppose one rule you are deciding time. So suppose any user coming to this particular role, admin role or any other role, if he is accessing the data within this 6 a.m. to 8 p.m. night, he can access. After this 8 p.m., he cannot access. So you are setting one rule. So rule is basically what? Your term and condition. I mean, that condition you are setting, that condition, if then else, if and else condition you are setting, that is rule. It is extension of attribute base. So you are telling location, but in location also now rule is set. It should be less than 500 meter, then only you can access the data. So role is the doctor. Now attribute is email ID or location, but location should be what? Location should be within this range. So this is one rule you are creating. So this is extension of your attribute-based access control. These two attribute-based access control and rule-based access control must be utilized as a hybrid approach of the access control mechanism, right? So same rule-based access control basically must be used with RBAC, I mean role-based access control. So this is generally used with the set of defined rules, if then condition. If this is the condition, I mean this rule is matching, then only access will be granted. Otherwise, this access will not be granted actually, right? So a specific criteria we are giving. So with that particular criteria, if everything is matched, then we are giving the permission. Otherwise, deny the permission, deny the access. That's all. Now, basically, these rules can be based on the factors, maybe time, location, the IP address. So suppose this range to this range. If this range to this range, if this range to this range, it is used, then we can say what? Then we can say that this IP address is the valid IP address. So your organization will have their own IP address, and if your role is using that IP address, then you are deciding. So this rule is created. Rule is created by that organization. So centralized person is there who is creating this rule. So if any rule is holding that rule in terms of time, in terms of location, in terms of IP address, in terms of email ID. So suppose you are telling that if you are not using email ID of LUT University, you cannot access the information, right? So if anybody's role is trying to access with a Gmail or some other mail ID, they cannot access. So one rule is created. So this, if this range of IP is followed, then it will be accessed, otherwise it will not be accessed. So it is extension of attribute based, but some rule is set. So that is actually, that's why it is known as actually rule based access control. So I mean, one example also we can think like that. Suppose IoT device is uh, reading the data, I mean getting the data from the environment, and you are checking that if temperature is less than this, then data should be given to the model, otherwise it should not be given to the model. This all kind of scenario you can think in terms of rule based access control. So this rule based access control is extension of attribute based access control. So some policy you have to enforce, some rules you have to design, and that rule may be on the different set, different condition, time-based, location-based, system-based restriction. So system-based restriction is IP addresses and all. All these things you can handle with this rule-based access control permission. So like rule and condition is written time-based rule. So 8 a.m. to 6 p.m. if anybody is trying to access the information, you can access, otherwise no. Location-based, if private, internal network on-site or secure VPN is used, then can be accessed, otherwise this can be denied. Within the range of 500 meters. So all this location based or in network based, every rules will be set. Some other multi-factor authentication you can do. So suppose a user is first you have to ask the password of the user, then second label you can ask mobile number and generate the OTP you give. Then third label authentication, you can type the user will type the mail ID, again one OTP will send. So all these three level of authentication, in level of authentication, two level of authentication, this all can be done in the rule based access control. So that kind of permission access granted is, access permission is known as rule based access control. So two level authentication, three level authentication, that comes under the rule based access control. So same rule based access control, one example scenario is given. So one finance employee attempting to access the customer record at 7 p.m. Would be denied because time is given was up to 6 p.m. One finance employee can access the information, otherwise will not access. So if any analyst is trying to access the sensitive data without the connecting to the secure VPN of the company or organization, he will not be getting, access will be denied. So similarly, an executive who tried to financial restriction without passing the multi-factor authentication, then you will denied. So all this factor of authentication, in number of factor of authentication uh, is a rule actually. The rule is designed and managed by that particular organization, right? So organization has set some rule. Then every rule has to manage that particular rule before getting the access permission. So this comes under the rule-based access control permission. So once system admin is there, he defines rules, all the criteria, and based on that, this role will be checked. So role based and plus that criteria. So role is one of the criteria. Role is one of the access permission. So particular admin is the role, but in that there is an attribute email. In that also one set of rules is there. Email must be in the organization. You have to use organization email. So this is one of the rule. So role is admin trying to access the data as the attribute location. But again, rule is less than or equal to 500 meter. That is one rule. So role plus attribute plus rule, this can be combined, and you can say that this is the hybrid approach of access control permission. So all these three can be combined. And rule base is nothing but extension of your attribute base with some if and else based set conditions. So, again, rule-based access control is basically granular control, because everything, fine-grained access means everything, every attribute you are checking, not only role. Now, every attribute also you are checking, plus in that attribute, some rules also you are checking. So, this is actually known as fine-grained access control. So, fine-grained access control means every role, then attribute, each attribute, some rules are there. So, all rules will be checked before giving the permission of any resource. The resource can be anything basically, right? So enhance security for dynamic access need. Here dynamically we can check so that location within the range, within not the IP address range. So all this kind of information can be checked at the dynamic dynamic access. So rule-based access control can be used alongside role-based. Obviously, you have to on role-based and attribute-based. Yes, so all three can be combined. As I told you, this can be used as a hybrid approach of access control. So whenever you are using role-based and attribute-based, you can say hybrid approach of access control. Even if you are using role-based, attribute-based, and rule-based, this can be also hybrid approach. You can also make hybrid approach what? Role-based and then rule-based. This can be also one hybrid approach. So this can be used as a hybrid approach of access control model. So in level of security, multi-layer security, multi-factor security, these all terms comes under the rule-based access control. But yeah, I mean, some emergency access policies should be designed. So at some time, suppose some emergency crisis is happening in that time, some security should be breached because admin has to bypass something, bypass some rule, certain rule in emergency to manage the different issues. So emergency access policy must be designed because if fine grained you are making, fine grained means each and every attributes you are checking, but when it comes in the crisis, then this rule, some security should be, bypass by the admin to manage these all attributes, role, and different rules. So this is the basically one example use case. So emergency access policy also need to be designed whenever you are designing access control policy with role based, attribute based, and combining rule based. If all three you are combining and making access control policy, then you must have to design emergency access policy. At what time? I mean, if anything happen in the crisis, then at that time how particular access control will be managed. So in that case, some of the bypass rules should be there. So that policy need to be designed. So matrix you have to design for emergency access policy. So this limitation, complexity, and multiple rules we are restricting. So these rules, to manage these rules is complex. I mean, again, for admin, it is basically overhead because large organization, different rules are there, different attributes may be there for one rule, maybe there for one resource, but it is not necessarily one resource we are managing in one organization. We can have n number of resources. In that scenario, different attributes will be there for your resource, different attributes will be there for different roles, and that too, each attributes you are making some different rules. So it is going to very complex to manage this. Then same limited flexibility for user needs. So it happens, I mean, daily routine service. We are accessing ERP services, and today some rules are changed. We are unable to access the dashboard because rules is changed by the admin generally, right? So if rules is changed by the admin, you will not be able to access. Sometimes it is kind of, a limited flexibility for the user, right? Because sometimes user gets frustrated also. I mean, this rules is set by admin. Now today is set, tomorrow they have removed particular rules. Now due to that rules, you are unable to access the resource. So that also one of the limitation of this rule based access control model. Now these are some comparison which I'm not going to read each and everything, but whatever we have discussed, based on that, some features, based on that feature, I have given this, difference between the mandatory access control, discretionary, role-based, and rule-based. So basically, what actually we learned, discretionary access control, where owner was the everything, owner was deciding who can access my data and changing the permission. Then to owner can misuse that particular permission, grant and revoke. Then mandatory access control came. Mandatory access control say that now one admin will be there, centralized authority will be there. He will decide all the particular resources, and he will classify the resource in different category, and that category is known as sensitivity level. And then user will have the clearance level. If suppose one user is having clearance level 3 and security sensitivity level of the resource is 3, then he can access level 3 resource as well as 2 resource and 1 resource. So all the below set of security level he can access based on his clearance level. But it is very difficult to decide in the larger organization when resources are more, which resource should be kept in which of the security level. That is very difficult. Then to that, actually another kind of access control came, that is role based access control, where a smaller set of group can also apply this role based access control. So one team is working in one project, they will be using different set of role and different set of permission. So role based access control can be used. In that role based access control, it was known as course based access control. Why? Because we are taking role as a larger, access control rule. But whenever the problem is we are not considering any attribute. If you are considering, maybe in the admin position there will be 2 3 admin, or all 2 3 admin can access all the data. No, director of finance will have different access, director of particular different uh, department will have different access. So even they are coming in the some admin label, some attributes should be there. Their department should be the attribute, something should be the attribute. So in role based, one another kind of access control came, attribute based access control, and these two combinedly known as hybrid based access control to give the permission to the user. Then in role based access control also one another kind of extension came, that is rule based access, attribute based access control. Again another kind of access control came, that is rule based access control, where particular rule is also checked. Attribute is there, but in attribute also condition is framed, and if condition is matching, then particular role will get the access, otherwise a role will not get access. So this all combination of role based, attribute based, hybrid approach, role based and rule based is hybrid approach, role based, attribute based, and rule based is known as hybrid approach. So all three different types of scenario can be created for a hybrid approach of access control. Now we will see overall component of access control, because all access control, whatever access control you are using, whether mandatory, discretionary, role based, or combining this role based, attribute based, combining this role based, rule based, combining role based, attribute based, and rule based, every access control must follow this IEEE components. So identification, authentication, authorization, and audit and monitoring. So unique ID should be given to each and every username, that is telling in the identification. So suppose we are taking as a user ID of the student, that can be the identification of the role. Then that particular user must be authenticated before access. So you should have, that can have multi-factor authentication. There can be multi-factor authentication, password, biometrics, or any kind of authentication should be there to manage this access control. Then authorization, if particular user is authorized, then resources can be granted or denied. Then monitoring should be there, proper monitoring, log monitoring, access, permission, everything should be monitored. So this IEEE is the standard overall key component of the access control. Now, basically benefit of access control, what we will see, this enhance the security. So control access sensitive information, reducing risk of data breaches, right? So whenever we are designing access control, it enhances the security. Obviously, unauthorized cannot access the data. It's very simple. And then compliance with the regulation, it should follow, right? So as you can see, suppose health industry is having their own access control rules act. They have designed one act. So whatever access control you are making for health insurance portability and accountability act, it should not violate this act actually. So access control, whatever you are maintaining, it should not violate this kind of already predefined access control standard. So you cannot design any access control which is not coming under this particular act. So this should be taken care, right? Now data integrity, then user accountability, these all terms should be is the benefit of designing of access control in cyber security. Now what are the challenges? Basically escalability is one of the challenge. Why? Because if once organization grows, so managing more user, rules, attributes, rule, everything will become complex. Then what is the solution for this? Basically, the solution is either you divide in a smaller group of team, a smaller group of project where the set of users will be less, and then this kind of access control can be used either in the mandatory access control, role-based access control, or whatever access control we are trying to adopt. And basically human error will be there, because as we have seen actually discretionary access control, only one user is there and he is accessing everything, he is giving the permission I mean, he the owner, he deciding who can access his data. So human error is there. And in other also like mandatory access control or role-based access control or this attribute and rule-based access control, one centralized authority is there, right? So third-party services, that is what TPS, third-party services is giving the role and the particular access based on his attribute or based on the particular rule. So these all things is handled by this somehow centralized authority, so that human error will be there. So suppose today one user is added in particular role and tomorrow that role is actually revoked. I mean, it was granted, but it was next day it is revoked. So he will not get that particular services. So all kind of human error will come, right? So this policy, maintaining this policy, as I told you, that GDPR policy, that HIPAA policy, then PCI DSS policy. So only two, three policy I have written, but every organization is having their own access control policy act. So whatever policy you are making, you should not violate that policy act. So this you should be you should maintain while designing your access control. So these are the challenges basically. Then some best practices are there. I mean, grant user minimum level of access necessary to their roles. I mean, more than one role you don't give, more than two role you don't give. So if you are giving two roles and that two roles is having different attributes, then again he will be accessing some different resource. That resource will again having some different attributes. So maintaining all this, I mean, these things will be difficult. So as much as minimum level of access necessary you give to the role, and regular audit and review should be there. Multi-factor authentication should be there, and every user should be trained based with the best practices. So all these security breaches should not be there. And then a dynamic access policy. So change condition, user roles, thread labels, everything should be checked in the routine ways. Then this is actually future research direction, access control future research direction. So one research focus I have taken, integrating artificial intelligence and machine learning with role-based access control and rule-based access control to enable adaptive dynamic access control. What is the description of this particular research is? Suppose an organization becomes more complex, static role and rule assignment can lead to excessive privileges and security vulnerabilities. Obviously, because you are assigning different roles and different based on different attributes, so vulnerabilities will be there. So why not to make one AI ML model to monitor the user behavior? So if user is doing something different than normal, that model will detect that particular role. So this role is doing something not normal, is different actually he is doing. So that can be detected with the model. So this is one set of future research direction can be used in terms of access control. So inside the role-based access control, different roles are there, but if any roles is doing some disturbance in the access permission, then how to detect particular role? You can design one AI ML model where you can track the behavior of the particular role, and based on that, you can detect it. So this is one of the very good problem on adaptive role and rule management using AI. So basically, adaptive role and rule-based access control management using AI and ML. Then again, next is actually context-aware rule-based access control and role-based access control, rule-based access control for IoT and edge computing. So again, problem statement given, research focus, developing context sensitive. Context sensitive means in terms of location, in terms of device state, all these things comes under the context sensitive. So developing context sensitive role-based access control and rule-based access control models tailored for the Internet of Things and edge computing environment. See the description actually. IoT and edge devices often requires access control based on the environment factor. So suppose location is this. So your IoT device is used in a nearby location, and uh, device state is another things. So suppose your device is uh, uh, capturing the temperature. Now, how you can make it actually that temperature you can distribute in the distributed system. Suppose you are using distributed IoT ecosystem. So how you can manage this? So all these kind of things comes under the current research trend where context, where location and time, everything is everything becomes essential, and managing the access control over this location and device state is mandatory. And thus you can use rule-based access control here with the different rule, and you can manage this for the IoT and edge computing based scenario. The next actually I have taken decentralized and blockchain based role and rule management. Again, research focuses using blockchain and decentralized technology to manage role and rules for improved transparency and security. So, I mean, as you know, decentralized system blockchain generally offers temper-assistant access control. So, by storing rules, so permission rules over the blockchain ledger. So, whenever we are designing this blockchain-based infrastructure, where different role should have different type of access based on their role actually. So suppose you are making supply chain management. The supply chain management, manufacturer will be there, distributor will be there, retailer will be there, consumer will be there. So all these different roles should be addressed based on their role, based on their attributes, based on their location. So all these attributes based, role based, everything should be managed properly in this blockchain based scenario where data is transparent, uh, temper assistant, but even temper assistant is there. But if you are not maintaining the role of the different user, it's going to be very difficult in the decentralized infrastructure, because nobody is centralized in that. I mean, centralized authority is not there to handle these all different set of role. So you have to design such access control permission where each user will have different roles. You have to check the attributes of that particular role. Maybe you have to apply some rules. So in that case, challenge is to design lightweight consensus mechanism, and to manage the large set of large set of users, computation, where delay will be there, latency you have to maintain. So all these things will comes under one kind of resource direction, where different set of users are there, different access control you have to maintain. As I told you, supply chain manufacturer will have the different access, maybe distributor will have the different access permission, then retailer will have different access permission, then consumer will have different access permission, and even individual, suppose individual user will have the different set of permissions. So all permissions should be managed properly based on the role, based on the rule, based on the attribute, everything. But to manage this, because your blockchain system is not centralized, any admin is not controlling this. So in that case, you have to use what? Some consensus mechanism you have to design in such a way that these all rules should be managed by your consensus. In access control implementation, we can see, I mean, DAC implementation, MAC implementation, rule-based access implementation. So all we will see. So I think we can go here, DAC code. I have written over the blockchain basically. This is nothing but, see, it is one of the code I have written in Solidity. This smart contract basically, nothing is. I think we can see one scenario. What actually I have done here is customer loan system. I mean, I'm storing the loan information of customer on blockchain network. So for that, I have designed this smart contract, right? So I mean, what actually I have done here is, see this structure first. What is this structure is? Customer structure is there, and I am storing what is the customer name, what is which bank name, what is the bank name, how much amount he has taken, at what date he has taken, and what is the current CIBIL score of that particular customer is, and what is the customer address. So all this information basically I want to store in the blockchain network related to one customer loan service. So suppose banker is the owner of this particular transaction. So banker is deploying this data, who is the customer, how much the amount taken from the bank, at what date he has taken, what was the CIBIL score. So banker is the owner, right? So this is basically discretionary access control we are maintaining, right? So owner will share the data over the network. So owner, so in blockchain network, we are having actually message.sender. Message.sender is basically gives who deployed the contract. So suppose bank manager deploying the contract, and bank manager is sharing all the detail over the blockchain network so that other person can only see the data. So this is discretionary access control. So bank manager is the owner of that particular data. So information, customer name, bank name, amount, and what date he has taken, and what was the CIBIL score and all, address and everything. So this data should not be modified by any other person. So access is given or granted, I mean granted and revoked by this particular owner, bank manager, right? So I am assuming that this particular owner is the uh, owner is having control over this data. So what actually we are writing actually in blockchain network, we are having modifier and we are checking here. So whenever anybody is try to access the information, I'm checking whether he's owner or not. So if owner, this is actually constructor. So when it runs in at the initial level itself, I'm storing the owner data. So when this contract is deployed, I'm storing the data in owner, and I'm checking every time if owner and the deployer who initially deployed this contract same, then it will run. Otherwise it will give one error, caller is not the owner. So actually what was the motto to this? See, one function I have designed, set data, and I have given one restriction here, only owner can set the data. One restriction is there, only owner can set the data. So if only owner can set the data, this is the DAC actually. So owner is having permission, owner want to only set the data. Then other cannot set the data, other cannot set the data of particular customer, bank, amount, date, CIBIL score. This can be only set by the, this should be only set by the bank manager because he is the owner of the transaction. Now again, one function I have designed for get data where I am not writing anything. Actually, this function should be accessed by everybody. So this access permission, read permission, basically read permission. This was the write permission, right? So write permission can be only done by the owner, and read permission can be done by anybody in the particular group or organization, right? Similarly, if any information is deleted from that particular list, then only owner can delete the information. Other user cannot delete the information. Similarly, if any update is required, only owner can update the data. So this is kind of what? This is kind of basically discretionary access control. So owner is the bank manager and he is giving access, only read access to the other user. Other user can only read the data. As you can see the function get data. In get data, there is no, if I'm writing only owner here, if I'm writing only owner, then this is also applicable for only owner, means only owner can access this, only owner can access it. But as read data, get data means only read data. So read data can be accessed by any other user. So actually here I'm not writing this only owner. So owner is the bank manager. Bank manager can share the data. So only owner here I have used. Bank manager can delete the data. So only owner access permission I have used. Now owner will decide who can access what. So owner had decided that other user can only read the data. So this function is basically reading the data. Other things cannot be done. So this is one way of DAC implementation. The other way of DAC implementation is this one. So this is again same thing actually I have taken. This is again same thing, same customer information and all. But only thing is this time I am storing one user wallet address or user address you can say. And what actually I'm doing, if owner is the access person or this user is the access person, we will allow. Otherwise, we will not allow. What is meaning of this? I have given one user access if he is the person If this address is there, if this address is accessing this information, we will grant it, otherwise we will not grant it. It's very simple. So what actually is done? Now set data will be done by only owner. This actually get data, I mean reading the information can be done by anybody. Then delete data can be done by owner. And then here actually I'm writing only owner, but if I'm writing comma underscore user only, underscore user underscore one. What is user underscore one? User underscore one is this one. User user underscore one is this one. So if this address also want to access or update the data, we can give the permission. So if we are giving delete permission, this user can delete the information. So now we can write this delete data function can be accessible to owner as well as this user. You can also store the address, other address, let's suppose underscore user underscore 2, and his wallet address you can store. What is the wallet address? And then you can give one or operation, and you can write it underscore user underscore 2 equal to message dot sender. I will share this code actually. So I will share this code and you can execute it also. Then you can say that user 2 can also access wherever you will write this user 2, wherever you will write this user 2, that will be, suppose set data function public only user, and now you can write underscore user underscore 1. So these two can access this. Now you owner can also access this and user 1 can also access this. So owner is telling that this address can also access, so he can also become one set of owner. And which function he can access, there this user underscore user one will be added by the owner. So this is another way of implementation of your DAC model. Now other role-based access control is also designed. Here actually I have taken in the book information. So this is mandatory access control, right? This is mandatory access control where different role is there. So reader role is there, librarian role is there, and admin role is there. So enum actually I have used enum. And then user in user structure, I'm storing the wallet address of the user, at what role, and whether he is registered or not registered. If he is registered, then he can access, otherwise he cannot access. Then similarly, book information. So book ID, then book title, who is the book author, and whether book record exists or not exist. So mapping, very simple mapping is there. So based on the address, wallet address, user structure will be mapped. Based on the book ID, book will be mapped. So actually here role is checked. If user and message sender dot role equal to role dot admin, then access is given, otherwise access is denied. Only admin role. Only librarian role, method dot sender and dot role is equal to role dot librarian, or user dot role dot admin, then permission is granted, otherwise access denied, librarian admin only. So librarian and admin, some other role is also created, only reader or higher authority. So based on that, actually you can create the role. Role is equal to reader, role is equal to librarian, role is equal to admin. So all these three role want to access, then one role is created with this. And if it is success, then this underscore semicolon is basically nothing but success, nothing but success. So all this, any role is matched, either reader, either librarian, or either admin, access will be granted, otherwise access will be denied. So this is actually thing. Now the thing is, you can see here, register user registration is there. So we are taking one address. I'm taking one address and the role, at which role and what is the address, wallet address. And then based on the wallet address, if it is exist, then user already exists, otherwise this user role will be created. One record will be created with this particular wallet. In that, his wallet address, his role, and true means exist, as we have taken boolean exist. So this data will be added, right? So this is one way. One book is added based on the ID. Actually, we are adding book ID, a book title, book author, and book whether exist or not. So all these things, I mean, user registration, book registration, we can do with a different rule, right? Now, if trying to access, then what actually we are checking only reader or higher. Who can access reader or higher? Either reader or librarian. You can see the rule actually you have assigned only reader or higher. Role should be reader, role should be librarian, or role should be admin. All these three can access this information. Similarly, this is only for the admin. So here actually it is written only admin can access, right? This can be only accessed by the admin, so only admin is accessed. So this role with some description is also given in each code. So if you go with this, so these are the role, these are the access control modifier we have used, only admin, only librarian or admin, and only reader or higher means reader, librarian, admin both. And these are the functionality who can access what. So this is mandatory access role-based access control is designed based on this. Role-based access control is designed based on this. So all this actually implemented. Rule-based access control is also implemented. The hybrid approach I have also implemented, MAC and attribute-based access control. So I will share all this code. I think then you can check. I mean, this is actually what a MAC-based mandatory access control. Well, different clearance level is given for the user, and different sensitivity level means, or you can say security level is given for the transaction or user. So 1, 2, 3, the labels, then sensitivity level, and then while registration, what actually we are adding user address, his department, and at which label actually he want to access the information. So if his label is 3, he can access the information of label 3. He cannot access the other information. If, I mean, label 3 can access the sensitivity level or security level 3. If label 2 can access the label 2 and 1. So higher level can access the lower level as well as that particular level. So label 3 can access label 3, 2, 1, all this information. Getting the point? So this is the one way, right? So this entire thing, MAC access control is implemented. If you go through this, very simple, everything I have written in the below, if you go this, you understand each and everything. I will share all the information, right? And you can execute this in the remix. First, you can check this in the Remix Ethereum code itself. How to check? I think I should show you how you will check this. So control A, not here, from up to here. So this you can go and okay, now let me remix Ethereum. Let me show you. You can check it also. I think that will be fine. Mm, okay, attribute-based access control already I have executed here. So attribute-based access control, where clearance level is added and sensitivity level is added. Now this is running. Actually, this compilation is successful. It is showing compilation successful. You can go to the deployment, and once you will deploy this, you will get the all functionality. So deploy this contract. Once you deploy this, you will get this functionality here. So all this functionality you can see here: add book, delete book, register book, update book, admin. So if I have deployed, then I am the admin. You can see this is the wallet address, or this is the address, you can say it is showing. So this is the account address. The account address, what is the account address? C4 is the account address, last C4. As you can see, last is C4. As you can see, this one last is C4. So this now this became admin. And as we have seen, admin now allow the roles. So now he is the admin. Now he can allow the roles to different address. Different address he will take, and he will give the admin permission. He will give the librarian permission. He will give the some other permission like user permission. So whatever reader permission, basically reader permission, librarian permission. So he is the admin. Now he can give all these uh, this address with a different role like reader or librarian. He can assign, as we have learned in the MAC access control. MAC access control means one admin will be there. He will give the different roles, and he will set the clearance level, and he will also set the sensitivity level of the transaction. So as you can see, all this function you can check one by one. So I will share all this code, right? So rule-based access control is also designed. I have set everything. I think once you'll go with this particular rule-based access control is also given. So every role is there, and based on role, some sensitivity level of the attributes is given, particular resource and sensitivity level. Then you can go and you can see different rules, different if so here actually it is one rules is given. If the sensitivity level means what, security level of the transaction is less than equal to 3, then only it can access. So one rule is there. So similarly, if security level is less than equal to 1, then only access is permitted. So all these rules are set actually. So this is rule based access control permission. So I'm going to share all this information uh, to this participant, right? So this is finally implementation part. So where some smart contract I have created based on the DAC model, MAC model, role-based access control, rule-based access control, MAC and attribute-based access control, that is hybrid access control approach. So all this PPT and that code also I will share to everyone. And I think this is the references which I have used before making this. And finally, thank you. So, Rehan,
Yes,
Thank
it
you,
was a
sir.
great lecture. It's
Yeah.
complete in details. It's
uh,
it's really great lecture, I would say.
thank you, thank you. So now I can stop sharing.
Yeah,
Yeah.
yeah, and maybe I can also
Oh,
stop recording also.
yeah.
Yes.
Okay, and now